looking at the function which I've drawn in red, you have 3 what's known as stationary points. Think of a stationary point kind of like a peak. So you have one stationary point here. You have another stationary point here. This stationary point, the first one, is known as a maximum because the rest of the graph close to it, meaning on either side, is below that stationary point. Where on the right hand side, this would be classed as a minimum because the part of the graph close to it is above. The third type of stationary point would be here. That part is known as point of inflection. Okay. Stationary points are when the gradient is 0. That's how you work it out. And your stationary points are coordinates. Now, let's say you don't have a curve. Let's say you don't have a drawing, and it's not possible for you to sketch a drawing. How do you know whether your stationary point is considered a maximum, minimum, or point of inflection? You would use your second derivative. Okay, so you take your second derivative, you plug in your coordinate for x. So let's say x equals a, for instance. You plug in a into your second derivative. If that substitution gives you a value greater than 0, then you have a minimum. If that gives you a value less than 0, then you have a maximum. If that gives you a value equal to 0, you can have either a minimum, a maximum, or a point of inflection. Okay, so that's how you work with it. So let's have a look at this question. It says, find the coordinates of the stationary points on the curve with equation blah blah blah. So first off, I want you to differentiate that function for me, please. So you should have gotten differential equals to 6x squared minus 30x plus 24. We're trying to find the stationary points. You can find stationary points when you make your differential equal to 0. 6x squared minus 30x plus 24 equals 0. I want you to now solve for x, please. Factorize out 6 and you are left with something like that. Put it into double brackets, x minus 4, x minus 1. So that means x equals 4 and x equals 1. Sub each x coordinate or x value back into your original equation. When x equals 4, y equals minus 10. When x equals 1, y equals 17. Those are the coordinates of your stationary points. 1 and 17. Cool. The second part of the question says, find d squared y by dx squared and use it to determine the nature of the stationary points. So, can you work out the second derivative, please? So you should have gotten d squared y by dx squared equals 12x minus 30. You sub in each x value. D squared y by dx squared when x equals 1 is minus 18. minus 18 is less than 0, which means 117 is a maximum. When x equals 4, d squared y by dx squared equals 18, positive. 18 is greater than 0, which means 4 minus 10 is a minimum point. There you go. You've now determined the nature of the stationary points. So, I want you to try E for me, please. So first off, you want to rewrite y as x to the power of minus 1. You differentiate, and you get 1 minus x to the power of minus 2, or this can be written as 1 minus 1 over x squared. Okay, you make that equal to 0. And now you can solve for x. So 1 equals 1 over x squared. So that means x squared equals 1. So that means x equals plus or minus 1. Because the square root of 1 is just 1. Okay. So when x equals 1, y equals minus 2 when you sub that in. Positive 2 when you sub it in. And then when x equals minus 1, y equals minus 2 when you sub it in. So those are your two stationary points. Minus 1 and minus 2. Cool. Your second differential would be 2x to the power of minus 3. Or you can write it as 2 over x cubed. When x equals 1, your second differential is equal to 2. 2 is greater than 0, therefore the point 1, 2 is a minimum. And similarly, when x equals minus 1, d squared y by dx squared is equal to minus 2. Minus 2 is less than 0, so the point minus 1 minus 2 is a maximum. There you go. That is how you do stationary points.